I studied ground-dwelling arthropod species richness and diversity in modified tropical landscapes in the pre-montane wet forest of Monteverde, Costa Rica. These are some of the major reasons arthropod diversity is important for habitat health and conservation. One of these reasons is that they make up the largest percentage of animal biomass in the world. That is represented in this diagram, where arthropods are depicted in green hues. Arthropods also provide us with beneficial ecosystem services such as those listed here. Because of their great role in maintaining a healthy ecosystem, many arthropods have been used as indicator species used to predict the condition of a habitat. It is also important to identify which modified landscapes are better at maintaining a higher diversity of arthropods in order to identify their loss or conservation. Deforestation due to agriculture has been the cause of more than 80% of Costa Rica's total deforestation. In this research, I identify the species richness, abundance, and diversity of arthropods in banana and coffee plantations, as they are some of Costa Rica's largest exports. By using arthropod presence and biodiversity as indicators of habitat health, I sought to identify which of these landscapes maintained a more similar habitat to an undisturbed patch of forest. Research shows an inverse trend between species abundance, richness, and diversity and disturbance. Therefore, from the landscapes that I studied, I expected the coffee plantation to have the lowest values and the undisturbed patch of forest to have the highest values of the metrics studied. The sites studied were an unaltered patch of forest, an organic banana plantation, and an open sun coffee plantation. Arthropods were collected in these sites using the pitfall trap method. The arthropods collected were organized into a total of 73 morphospecies in 14 orders. These pie charts show the relative abundance of each order in each of the sites. The largest portion of each has been blown up. The largest order in the forest was beetles, in the banana plantation spiders, and in the coffee plantation ants, bees, and wasps. These graphs show the abundance of species richness of each of the sites. In both, forest had the highest values and banana the lowest. My results also showed that banana, although having had the lowest abundance and richness, was the most even habitat. As expected, the forest had the highest diversity and coffee the lowest. The forest and banana habitats were the most similar, with a percent similarity being 52%. My results show that both disturbances studied are worse for the diversity of arthropods than unaltered forests, but organic banana plantations, like the one studied, aid in maintaining more arthropod diversity than sun coffee plantations. My findings suggest that sustainable agriculture practices, such as those used to maintain the banana plantation, provide habitats that are more comparable to a natural habitat and therefore can maintain a higher amount of species diversity. In the effort to conserve arthropods, it is important to understand their role in agricultural habitats and the services they provide in order to assess more accurately the effects of continual habitat destruction.